You've mentioned that Dojo 3 will be used for space-based compute.
You really read my what I say.
I don't know if you know Twitter, but I know you have a lot of followers.
Big giveaway.
How do you?
How did you discern my secrets? I post them.
How do you design this chip for space? What changes?
Well, I guess you want to design it to be more radiation tolerant and run at a higher temperature. So you could, roughly if you increase the operating temperature by 20% in degrees Kelvin, you can cut your radiator mass in half. So running at a higher temperature is helpful in space. There's various things you can do for shielding the memory but like neural nets are going to be very resilient to bit flips. Yeah. So like most of what happens for radiation is like random bit flips. But like if you've got like, a multi-trillion parameter model and you get a few bit flips, it doesn't matter. It's much like heuristic programs are going to be much more sensitive to bit flips than some giant parameter file. So I just designed it to run hot, and I think you pretty much do it the same way that you do things on Earth, apart from making it run hotter.
The solar array is most of the weight on the satellite. Is there a way to make the GPUs even more power dense than what NVIDIA and TPUs and et cetera are planning on doing that would, be especially privileged in the space-based world?
Well, the basic math is like, if you can do about a kilowatt per reticle, and then you'd need, 100 million full reticle chips to do 100 gigawatts.
Yeah.
So, depending on what your yield assumptions are, that tells you how many chips you need to make. But cool, you need if you're gonna have 100 gigawatts of power, you need 100 million chips running that are running a kilowatt sustained output per reticle.
100
basic math.
100 million chips. It depends on. Yeah, if you look at the die size of something like Blackwell GPUs or something, and how many you can get out of a wafer, you can get like on the order of dozens or less per wafer. So this is a world where if we're putting that out every single year, you're producing millions of wafers a month. That's the plan with TeraFab? Millions of wafers a month of advanced process nodes?
Yeah, it's going to be some number north of 1 million, I think. You got to do the memory too.
Yeah. You're going to make a memory fab?
I think the TeraFab's got to do memory. It's got to do logic, memory, and packaging.
I'm very curious how somebody gets started. This is like the most complicated thing man has ever made. And obviously, if anybody's up to the task, you're up to the task. So you realize there's a bottleneck, and you go to your engineers and what is the next, what do you tell them to do? I want 1 million wafers a month in 2030. Yeah. What is the next, what do you...
That's right.
Do you call ASML? What is
That's exactly what I want.
What is the next step?
That's so much to ask.
Well, we make a little fab and see what happens. Make our mistakes at a small scale, and then make a big one.
Is a little fab done, or is
No, it's not done.
Okay.
People would. They're not going to keep that cat in the bag. That cat's going to come out of the back room. There'll be like drones hovering over the bloody thing. You'll be able to see its construction progress on X, right? In real time. So no, I don't know. We could just flounder and fail here. To be clear, it's not success is not guaranteed, but. Since we want to try to make, something like 100 million. Yeah, we want 100 gigawatts of power and 100 chips that can take 100 gigawatts, right? So call it, by 2030. So then, and we'll take as many chips as our suppliers will give us. I've actually said this to TSMC and Samsung and Micron. It's please build your more fabs faster. and we will guarantee to buy the output of those fabs. So that they're already like moving as fast as they can. Like it's not like, to be clear, it's not like us. It's not like either. It's not like it's us plus them.
There's a narrative that the people doing AI want a very large number of chips as quickly as possible, and then many of the input suppliers, the fabs, but also the turbine manufacturers, are not ramping up production very quickly.
No,
and the explanation you hear is that they're dispositionally conservative. They're Taiwanese or German, as the story may be, and they just don't believe this AI. Is that really the explanation, or is there something else?
Well, I mean, it's reasonable to, if somebody's been in, say, the computer memory business for 30 or 40 years.
And they've seen cycles.
They've seen boom and bust 10 times.
Yeah.
So that's a lot of layers of scar tissue, so it's like during the boom times, looks like everything is going to be great forever. And then the crash happens, and then they're desperately trying to avoid bankruptcy. And then there's another boom and then another crash.
Are there other ideas you think others should go pursue that you're not, for whatever reasons, right now?
I mean, there are a few companies that are pursuing new ways of doing chips. But they're just not scaling fast.
I don't even mean within AI. I mean just generally.
I'd say people should do the thing that where they find that they're highly motivated to do that thing. As opposed to, some idea that I suggest. They should do the thing that they find personally interesting and motivating to do. But going back to the limiting factor, use that phrase about 100 times. The current limiting factor that I see in the time frame, in the sort of 20, 29, 20, in the 3 to 4 year time frame, it's chips. In the 1 year time frame, it's energy, power production, electricity. It's not clear to me that there's enough usable electricity to turn on all the AI chips that are being made. Towards the end of this year, I think people are going to have real trouble turning on. The chip output will exceed the ability to turn chips on.
What's your plan to deal with that world?
Well, we're trying to accelerate electricity production. I guess that's maybe one of the reasons that XAI will be maybe the leader, hopefully the leader, is that we'll be able to turn on more chips than other people can turn on faster. Because we're good at hardware. And generally the innovations from the corporations that call themselves labs, the ideas tend to flow. It's rare to see that there's more than about a 6-month difference between the ideas travel back and forth with the people. So I think you sort of hit the hardware wall, and then whichever company can scale hardware the fastest will be the leader. And so I think XAI will be able to scale hardware the fastest, and therefore most likely will be the leader.
You joked, or were self-conscious about using the limiting factor phrase again, but I actually think there's something deep here. And if you look at a lot of things we've touched on over the course of it, maybe kind of a good note to end on. If you think of a senescent, low agency company, it would have some bottleneck and not really be doing anything about it. Mark Andreessen had the line of most people are willing to endure any amount of chronic pain to avoid acute pain. And it feels like a lot of the cases we're talking about are just leaning into the acute pain, whatever it is. It's okay, we got to figure out how to, work with steel, or we got to figure out how to run the chips in space, or we'll take some near-term acute pain to actually solve the bottleneck. And so that's kind of a unifying theme.
I have a high pain threshold. That's helpful.
Solve the bottlenecks.
Yes.
Yeah.
So, one thing I can say is I think the future is going to be very interesting. And as I said, the Davos, I was literally at Davos, I think it was on the ground for like 3 hours or something. It's better to err on the side of optimism and be wrong than err on the side of pessimism and be right for quality of life. So, you know, your happiness will be, you'll be happier if you err on the side of optimism rather than erring on the side of pessimism. And so I recommend erring on the side of optimism.
That's that.
Cool. Elon, thanks for doing this.
Thank you.
All right, thanks, guys. All right.
Oh, great stamina.
Yeah.
Hopefully this didn't count as a pain in the pain tolerance.